Hello. This is Clint or Tech Prof. Today I'm going to have a bit of a longer video, and this is going to be a video where I basically build an entire software application for a bowling team and calculating their scores and their team score for a day, etc. And the reason why I'm going to do this is I'm going to highlight several things. One, starting code organization from scratch, the concept of modularity and breaking your code into separate pieces, and I'm gonna do things the wrong way and then fix them so you can see exactly why we do things that way, in addition to introducing quite a few new concepts around arrays, around the ability to have an array of more than just a basic type like string or integer, but having an array of text boxes, for instance. And then also the idea that you can actually make testing your application a lot easier and reduce the amount of manual entry you need to do during the testing part of your application. So we're going to do that, and let's get into it right away. So what I've got here is I have pre-built a form. I can show you the code here. Inside the code, there is literally no code. It's just the basic code that we have in here. So this form is just the form itself. I've already done things for AODA or accessibility laws, such that I have keyboard shortcuts. I've got my tab indexes done. I've used a good set of contrasting fonts, legible fonts, contrasting colors, and I've set my accept and reject buttons to be the accept button. So the enter key will do the calculate button, and the escape key will do the reset button. So that's where I've got that started. I haven't put tooltips on here, and that is also required under AODA, but I'll have to do that another day. All right. So let's go ahead and get started with the code. But before I get to the code, I want to emphasize the fact that I want to finish this user interface before I go ahead and start coding. I want to have this as finished as possible. So I want to name all my items. I want to make sure I've got everything all set up. So if I go to the properties window here, you'll see that every single one of these text boxes has a name. So this will be text box name 1. I'm probably going to change my naming schema to use Hungarian notation for my controls because I much more prefer that. But anyway, so name 1, name 2. For the games, I've named them text box score, and then I've got P1, G1, so meaning player 1, game 1, and then player 3, game 2. So they have a very specific naming schema. Now, this is not the best way to do it. You can typically build these on the fly, but I've done it this way for teaching purposes, as well as the fact that I have a very specific number. So there is always 4 players and 3 games. When you have a very specific number, sometimes you can just put it up there and go. If I had a situation where I didn't know how many players there were, or I didn't know how many games there were, I might want to build this form dynamically in programming. But for this particular example today, because I want to focus more on the beginner programmer than the intermediate or advanced, so focusing on the beginner programmer, I'm just going to put all the controls on the form before I start. So a couple things I'm going to do when I go to the code window here, a couple things is that I want to be able to visualize my form. So I'm going to go ahead and do a couple things. One, once my form design is done, I'm going to get rid of the toolbox. I don't need the toolbox anymore. The other thing is under the properties window, I don't need that very much. And the Solution Explorer, I don't need that very much when I'm in the coding window. So I'm going to go ahead and do that. The other thing is I want to be able to visualize the form while I'm coding. So I'm going to go ahead and go to the form and add this to a new vertical document group. And so that I can actually see my form up here, right above me here, at the same time as I'm writing code. And that's pretty important. For a beginner programmer, it's important that you can visualize your code while you're coding. So let's get into the meat and the guts of starting with brand new code. What do we do first? First things first is all these using statements are in there by default. And if you look really closely, you'll see that the System Windows Forms one is actually bright white, and the other ones are sort of a little gray. What that means is that they're not actually using all of these using statements. So they put them in there by default in the template, but they're not all being used. I don't want to take them out yet because the ones I'm not using, I don't want to take them out yet because I might actually use them in the code. So before I launch or go live with my program, I probably want to clean the ones that I'm not using out here. But for now, I want to get them out of the way. Like, they're in the way. It takes up a third of my coding window. So let's get them out of the way. And the way I'm going to do that is, yes, I could collapse them here, but this using ... doesn't tell me anything. So I'm going to use a region. So I'm literally going to go ahead and put a region in here, and I'm going to call it using, I gotta spell it right, using statements. Okay, so I'm going to go ahead and do that. And then I'm going to put in end region. And what that does for me is I'm going to use regions a lot for my code organization. So when I shrink this up, I've got a nice statement there. It says using statements. And when I do need to go in there, I just click there and I've got all my using statements. The other thing I'm going to do is I'm going to add a comment header. You really need a comment header in every single file that you do. Okay. And I do have some code I'm going to copy and paste over here. Okay. Just because for video length purposes. So I'm going to go ahead and do this and put my name and my information in there. I'm going to say what the date is when I'm doing this and typing it in. And I'm going to go in and I'm going to add author, date, description, and revision history. Okay? If you are a student, then you probably need to add your student ID as well if you're going to submit this as an assignment as part of a college course or whatnot. So then I can shrink that up as well. So get the comment header out of the way, but it has to be there. It's mandatory. Okay. Then you get rid of your using statement and those kind of things. The next thing is you want to look at this particular code. So we've got this class form. So this is sort of the main area of our form. And then we have this form main function. This form main is sort of, okay, this is the first thing it runs when you run your program, initialize component. And what that does is it actually executes in this form designer file. So if I load this form designer file up, if I go in here, you can see that the function is called initialize component, and that's what builds the form for you. It creates all the objects, it puts them where they are, it sets the properties, their location, their size, their point, their font, and all the properties are set through that initialization component. Okay, so that needs to be there. The next thing, and so, but we're probably not going to touch that very often. We're literally probably just going to leave that alone, almost never touch that. So the next thing we're going to do is all of our code will go in here, and we're going to have sort of three main areas of our code. And I'm going to create a region in advance for these three main areas. So I'm going to go ahead and create a region for global variable declarations. Okay. And I choose to do these in all caps just because I think it's more readable, but that's up to you. That's just the region names don't matter. I'm gonna have a section for the event handler, so button clicks and those kind of things. All right, so event handlers. Okay, and that's sort of a feature of what you would do in a .NET program especially for something like a Windows form or whatnot. And the third region I'm going to have is for custom methods and functions. Okay, so I'm going to go ahead and do that. Now, within the custom methods and functions, I'm going to have three areas. So I'm sort of thinking ahead about how I'm going to build my application. And by creating these regions in advance, I'm sort of thinking about everything I need. So I'm going to go ahead and put in another region here. And this region is going to be data validation. Okay, so I definitely need to have a series of methods and functions which allow me to validate the data to make sure that the scores put into these text boxes here are numbers, that the names have been entered and they're at least 2 characters or those things. So we need some data validation too. Functions. We're going to need some general functions or methods. All right, and what these may be would be something like set defaults, reset the form, populate some data. Okay, and the third region I have here is something that not a lot of people do. I like to do this when I have a form that has a lot of input boxes like this. And this is not official automated testing procedures or whatnot, but this is a very actual handy way to go ahead and allow yourself to make testing a lot easier. So what I'm doing is I have a testing section I'm going to build. And inside this testing section, all I'm going to do is I'm going to generate some random numbers, and populate these random numbers, populate these text boxes with some random numbers so that I can do some calculations. I don't want to have to type in 12 numbers every time I want to test this. 4 names and 12 numbers. It just takes too long. So I'm going to hit this testing button. It's going to fill in the form and go from there. I'm also going to make sure that that testing button will put in data that's not right as well, so that when I hit the calculate button, it will tell me, hey, something's not right. So I can test my error catching or my data validation. So that's sort of the idea. And we'll come back to that one in a few minutes. Okay. So when we have a form like this, we're going to start off with the global variable declaration section. And so we're going to develop a bunch of the functions we're going to need. So I'm going to start off with some constants. Okay. And I'm going to have my constants be, first of all, Pascal case. Okay. And I'm going to set them up here as some constants that are basically numbers that are never going to change. Okay. So maximum number of players is 3. Maximum games is 4. Okay. Then I also want to know that in a bowling game, okay, the minimum score that anybody can get in a game is obviously 0. So you're not going to get a negative score. Okay. And in a bowling scenario, the maximum score you can get is 300. Okay, so that's a perfect game, and it doesn't happen very often. So chances of getting 300, I mean, you pretty much have to be a player who's played for years and years and years to get 300, because you have to get 12 strikes in a row. But besides the point, I don't want to make this application about bowling. It's not. It's about programming. So just to let you know, if you don't know anything about bowling, the maximum score you can get is 300. That's all you need to know. The other thing I want to do is then I want to declare some arrays. And what I mean by arrays is when you have a form that has a ton of items on it like this has a ton of text boxes on it, what I want to do is I want to be able to use these text boxes in many, many ways. So for instance, when I go to calculate, and I'm going to skip ahead a little bit, but I want to show you. So when I want to do this calculate button, what it's going to do is calculate all the totals and everything. And it's going to have the average score, etc. So when I do this calculate button, it's going to create this event handler, which I'm immediately going to cut and paste into the event handlers region here. Okay. So there it is. It's in the event handlers region. And the first thing I'm going to do is I'm going to say, okay, before performing calculations, validate that all data is entered correctly. Okay, so we're going to do some data validation. Okay, and so we're going to go ahead and create a validation tool. So I'm going to say, let's create a Boolean variable called isValid. Okay, and we're going to say and that should be camel case, not Pascal case. Sorry. We're going to say isValid. We're going to say isValid is going to equal to validate. I'm going to create a method, a function called validate names. Okay. And validate scores. Something like that. Okay. So we're going to go ahead and be able to create that validate name and score. So we need to create these two functions. Okay. And so under data validation, we're going to create a private Boolean function called validate names, like so. Okay. And we're also going to create another function called private bool validate scores, like so. Okay. And so we know we need to create these. The next thing is that because this is a function that returns a Boolean value, we need to have a return value. So I'm literally going to create a variable called retval, okay? And then we're going to return retval, okay? And that way I'm literally getting rid of my errors right away. And let's assume that it's going to pass the test, and when we prove that it doesn't, we will fail it. Okay, so we're going to assume that these are going to pass the test first, and when it doesn't, we will reject it. Okay, so there we go. We've got our two functions set up. We've got all of our errors out there. If I build my application right now, it's going to build. So sort of way to go about the coding and the structure is to set these up with things that you absolutely know need to be there. Now we can go ahead and either write some pseudocode or we can do some stuff. I'm going to use the task manager for a lot of this stuff and to make sure that I have my to-do list is all there. And notice I've got some to-dos from another project in here. Let me actually clean those up and get rid of those so that they're not part of this application. Okay, so I'm just going to clean those up quickly so that my to-do list is in fact empty. Where did that go to? Oh yeah, right at the top, yeah. Okay. So I'm just gonna close those out and there we go. So now I can write my thing. So what I'm gonna do is I'm gonna say to do add data validation to check if names are a minimum of 2 characters. And I'm gonna use 2 characters because there's names like Lee. Lee would be a name that could be there. Those kind of things. Maybe some people use their initials for the names, those kind of things, right? So for me, I might say TP for tech rough. Okay, so that's kind of it. So now if we were to do this code, I could say something like this: if text box name1 dot text dot trim, I want to make sure I get rid of the spaces on that, dot length is less than 2. Okay, then I would say something like retval equals false. And I might want to do something like this: message box dot show. I need my IntelliSense to work here. So message box dot show player one's name is invalid. Okay, I might have something like that. Then I'm going to set retval equals false, okay, because I want it to fail. And there. Now what I'm going to do is I'm literally going to copy and paste this code 4 times, okay? And I'm going to change this to a 2, this to a 3, that to a 4, that to a 2, that to a 3, that to a 4. Right? And I've spelled invalid, so this is a perfect learning opportunity here. I spelled invalid wrong. So 2 things. 1, once I find myself doing this, like I need to validate all 4 of these name boxes. So this is what you would do. So is name 1 valid? Yes. Is name 2 valid? Yes. Is name 3 valid? Yes. Is name 4 valid? Yes. Okay. If any one of them want to fail, we want to tell the user that it failed, and then we want to fail the test. So this will return a false value. As soon as you find yourself copying and pasting code like this, stop, because you're doing it wrong. Okay. And one of the biggest reasons is because if you need to fix something, now I have to fix it in 4 places. So I have to do that, and then I have to fix it here, fix it here, fix it here. And how am I going to guarantee that I actually fix that properly? Especially since this is in a string. And it doesn't cause a program error. Like, it actually will run perfectly, but there's a spelling mistake in my application. And I have to fix it in 4 places. Okay? And so that's a really good example of how not to do this. Okay, so we're going to fix this right now by playing with some global variables. So what we're going to do is we're going to go ahead in the global variable section of our program here, and we're going to create a text box array. Okay, oh, gotta spell text box right. Okay, so we're going to create a text box array, and we're going to call that text box array player names. To see where I'm going here. Okay. So again, an array doesn't have to be integers or strings or doubles. It can actually be an array of text boxes. This is pretty cool. So we can then say, okay, so based on text boxes in players' names, let's go ahead and say which text boxes are in player names. Okay, so we're going to do this. In our form load event, so I'm going to go over to my form. I'm going to double click on the form. So it creates this form load event. Again, it's the event. So I'm going to copy and paste it right away and put it into my event section, which is up here, event handlers. And I actually want this one to be first because it is the form load one, right? So I'm going to go ahead and put this in the form load event. And what I'm going to do is I'm going to initialize this array with what is actually in it. Okay, so I'm gonna say right here on the form load event, and I have to do this on the form load event because the form actually has to load, and these text boxes actually have to exist before I do it. So I can't do this in the open global code area, because to be absolutely clear, this has to run first, because until this runs, these text boxes don't exist. So this has to run first. So anything that's in this global area is not guaranteed to run after this. Okay, so I need to make sure it runs after that, and the way to do that is, okay, let's do it in the form load event, because the form load event happens after it has loaded. Okay, so after it is loaded, these text boxes will all now exist. So I can say that player names, okay, so player names, exactly what I declared right here, player names, and actually I'm going to use Pascal case here, because this is going to be a global variable. Okay, actually no, camel case, sorry, camel case. So I'm going to use camel case. I'm going to say this equals a new text box array. Okay, and I'm literally in curly braces here going to state what text boxes are in there. So I'm going to go text box name 1, text box name 2, text box name 3, and text box name 4. And I want to make sure I've put them in that order. Okay, by putting them in that order, the index number of the array can actually correspond to this. So the index plus 1 will be this 1, this 2, this 3, this 4. There are better ways to even go further in the array, but this is a fairly good way to do this. Okay, so literally what happens is I now have these 4 text boxes as elements in an array called player names. So when I go back down here, instead of showing this, I can use a loop. So instead of doing all this stuff, I can say for each, so for each, and it's going to be a text box. So for each text box, and let's call it T box, okay, for each text box called T box in player names, we're going to do some stuff. Meaning, player names has 4 text boxes in it. So as we loop through the array, each text box will go into a variable called tbox, and of type text box. So we can now say if tbox.text.trim.length is less than 2, then we can messagebox.show, and we can say player. Now I don't know what the number is, but I remember I said the index number would correspond. So I need some kind of a counter here. Okay, so let's do a counter. Int counter equals 0. We'll start with 0. Okay, actually let's start with 1. Might as well start with 1. So int counter equals 1. And so we can say counter. And I'm going to put a plus plus here, because I'm going to increment the counter after I use it. So it'll put the number 1 here and then change it to a 2. So that'll work out nicely. Plus, and I need this to be a string too. So I'm going to put this in brackets and go to string, like so. There we go. Apostrophe S, name is invalid. Like so. Okay, semicolon. All right, I've got some code wrapping here, and because I've got my font a little larger because of I want it to be nice and readable on the screen. And then I'm going to say retval equals false, semicolon. And the last thing I'm going to do is I'm actually going to say exit. Okay, our break is what I put here, maybe. I think it's break. I think what break does is it's going to exit this loop. Okay. And so what'll happen is once I find the first error, there's no point in testing anymore. If there's an error, just say it's invalid and go from there. Okay. So this code right here basically replaces all of this. And you're like, well, I mean, it's pretty complex and it looks a little confusing and I don't really get it. But it's important that you do get it. And the reason why I'm saying that is because in this particular case, we have 4 people's names. What if we're a baseball team and there's 25 names? Are you going to do this 25 times? Right? When I do this, this is for each. Notice the number 4 is not here anywhere. So this will work whether there's 1 text box or 500 text boxes. And there's no change in the code whatsoever if there's 1 or 500. The only code I need to change is what text boxes are in this array. Okay? As I said before, there's a better way to put those text boxes in the array, but this is designed for beginner programmers, and I don't want to go too complex at this point. Okay? So the only thing you'd have to do to add more text boxes is literally add them to the form and then add them to this list. And that's it. All your other code will just work. This is what we're talking about when we talk about modularity, is breaking your code down so it can run in many different ways, and it doesn't matter how many you have. This code just gets reused over and over and over again. I will say that this part right here is probably a little confusing for new programmers, but just take a minute to think about it. Counter to string will print out the number 1 first, and the plus plus after the word counter says use it first and then increment it. So counter will be 1 to string, it'll use it, and then it will increment counter to 2. So the next time we go through this loop, it'll be a 2, print it, and go from there. So this actually works. I could put another line. I could just put counter here and then put another line down here saying counter plus plus, right? But why bother? I mean, I can do it all in one step. So that's no different than doing it as a separate step, okay? So that's really cool. And so I can really quickly test these names. And I think my program should actually run. So let's do a couple things. Let's go ahead and set this form property so that it's going to open up in the middle of my window. Center screen. There we go. And then I'm going to run this application. And let's run a couple tests. Okay. Crossing my fingers that it runs all right. Okay, so we got this up. We're going to hit this calculate button. Player 1 name is invalid. Okay. And notice it didn't tell me player 2's name is invalid. Okay. So if I put in 3 letters, it'll say there, oh, player 1's name is invalid. Okay, so something's not right there. It doesn't like player 1. Okay, let's see what happens if we put all of these in here like this. Okay, so it's not giving me an error here. Let's make one of them there. Okay, so player 1's name is invalid, is not working. So let's see why that's not working. Okay. It's almost like this counter plus plus is actually not working the way I think it should. Let's just test this. Let's just put counter plus plus down here and just have this being counter. Let's try that. Let's try and see what happens there. Okay. The other thing is that should be okay. So let's run this. Let's see if that does actually affect it. So maybe I was wrong. So let's go with this. It still says player 1's name. It still says players 1. If I go like this, so it doesn't seem to make any difference, but now you see it's not giving me any error. If I take this one away, now it gives me an error. So it is testing all 4 boxes, but for some reason, the message box isn't changing. Oh, because this counter is only going up if there's a problem. Aha. So I need to move that counter outside of the if statement. There you go. So there's that problem. So debugging is also part of this process in the testing. So now let's run this. This should run better now. So we'll run this here. We'll put this in. Ah, player 2. Okay. Let's put that in. Player 3. Let's put 4 in. It still says player 3. Put in some letters. And there we go. It's not giving me any errors. Perfect. Okay. So it's a matter of you can have some great ideas, but if you don't put them in the right place, they don't work. All right, so we've got that. That's awesome. All right, we've got the name testing, and we're going to return a variable. So inside of our calculate button, we said is validate names, validate scores, and go from there. So what we're going to do in here is we're going to say if is valid. Okay. Then we're going to go ahead and actually do our calculations. Like so. So, but before we go there, we do need to validate the scores. So we do need to include that as well to validate these scores. So let's go ahead and write that code. So first of all, I'm going to collapse some of these. So this is validate names. Let's collapse that up. Okay, this is validate scores. So we're going to work in here. So in order to do validate scores, we're going to need to put all of these text boxes into an array like we did before. So let's go up and do this again. So this time we're going to create a text box array, and we could have we could make a single array with 12 boxes, but since this is players and games sort of in the XY direction, this might be cool to use a two-dimensional array. So we're going to use a two-dimensional array. And ultimately, in the way we're going to use this, it doesn't matter whether you use a 1D or 2D array, but why not show a 2D array so you see it and you see that experience? We're going to call this scores. Okay. So we have a 2D text box array called scores. And it's grayed out right now because we haven't actually assigned it any values. In the same place we did before in the form main, we're going to go ahead and assign the text boxes to this. Okay. And the way you're going to do this is you go scores equals new text box array. And again, you have to put that comma in there. That comma means there's going to be two numbers in there. So that means it's a two-dimensional array. Okay. And then what you're going to do is you're going to use curly braces, and you're going to put each sort of dimension on its own level. So it's going to look something like this. Okay. And then ultimately what I'm going to do is I'm going to copy and paste this line in, so you'll get to see what it actually looks like. Okay. So it's going to look something like this. Let me copy and paste that code in. Okay. And there it is there. So again, because of word wrap, there we go. That's better. You can see that, still word wrapping here. There we go. You can see that we've got text box, and we're doing player 1, and then all of player 2, then all of player 3, and we're going game 1, game 2, game 3. So all 12 of those text boxes are in there. And again, there is a better way to do this, but for beginner programming, we'll stick with this understandable method. Okay. So we've got all those text boxes into this text box array called scores. So now what I have to do is I have this validate scores function. So what I'm going to do is literally do another loop. Okay. So in this particular case, we want to keep track of, we want to give a message to the user with respect to which box is failing. So we need to keep track of the current player and the current game. So I'm going to actually use a different way of doing this rather than the for each method. I'm going to actually use a for loop. And we did set these constants up here for max players and max games. So what I'm going to do is I'm going to go through players first. So we'll say for, and I'm just going to use the letter P for player. So int P equals 1. Okay. And we're going to say P is less than or equal to max players. Okay. Semicolon, P++. Okay. So that's going to be my looping through the players. So iterate through players. For each player, I need to iterate through games. Okay. I'm going to say I will say we. For each player, we need to iterate through the games. So inside of each player, we'll say for int g for game equals 1 semicolon g less than or equal to max games. There we go. Semicolon g++. And so this will automatically track which player and which game I'm on. So then what I'm going to do is I can use the indexes of the array in order to determine which one is which. Okay. And so because I've started with 1, I'm going to have the index being -1 because array indexes start at 0. So I'm going to go ahead and say something like this. If, okay, this is where we go. We're going to say if All right, we need to test if this is a score or not, right? We need to test if this is good. So I think what we're going to do is we're going to have to say test whether we can convert the string to an integer, and we're going to test parse. But I don't want to have to put it into a test and all that kind of stuff. So what I want to do is maybe just test everything, right? You might want to just test everything. So let's go ahead and look and think. Okay, so how do we go about testing these scores? Okay, so we've got this red val. We're going from players. Okay, so we can do this. We can say we want to test whether a score is numeric or not. Now, in a language like Visual Basic, you can use is numeric. That doesn't exist in C#. So you might want to do like integer.try parse, but then you have to like do output and what if it fails and all this kind of stuff. So I'm actually going to write my own little custom function here. All right, I'm going to create my own little function and call it is numeric. Okay, and so down here in this validation section, let me create my own little private function here. So I'm going to say private boolean is numeric, and it's going to input a string. Okay, so input string. Oop, gotta spell that right. Input string, and it's going to be called input value, something like that. Okay, and so what we're going to do is that whole try parse thing, we're going to actually put it in here. In order to do a try parse, we're going to use double because maybe it's going to be decimals. I want this is numeric to be generic. Okay, so what I'm going to do is double and just some temporary variable. The only reason why I have this here is because the try parse requires an output variable. Then we're going to return double dot try parse. Okay, and we're going to try and parse that input value. Okay, and remember that's going to return a boolean whether it was successful or fail. So that's what we're returning, is that boolean. But because the statement requires an output, we'll just output it to temperature to this temp variable if it actually succeeds. But as soon as we hit this curly brace, that temp variable disappears out of memory anyways and it's gone. So we only have this here because we have to have this part here. But what we want is a true or false return value from that. So here I can say if not is numeric. Okay. And now I want the text for that text box. Okay. So I'm going to say if not is numeric, scores with square brackets, player -1, comma, games -1. And again, I have to do the -1 because I didn't start at 0, I started at 1. Okay. So scores, player 1 -1, G1 minus G2, dot text dot trim. Cool. And then I need a couple more brackets here. Okay. So essentially this looks confusing, but I've created my own little is numeric one, which just does a try parse. And I could put the try parse here, but because of this whole out thing, it's just an extra couple lines, and to make it really clean and tidy, it doesn't work very well. So it's easier for me to create this little modular function down here that returns the result of the try parse and nothing but the result, which means I can put the result right here. So what this does is it takes each text box as I iterate through the nested arrays, the nested loops. It takes the text box that's in that array and takes the text property of it, performs the trim method on it, and takes the result that's inside that text box, tests whether it is numeric by putting it in here, and I only want to say if it fails, so I put the not in front. So if it fails, we're going to say message box dot show, and we're going to say score plus G, so score 1, score 2, or score 3 for player P is invalid. Okay, oh, we need some quotes in space is invalid, like so. Okay, so it stretches over so we don't have wrapping. Okay, so message box score 1 for player 1 is invalid. Pretty cool. And retval equals false, semicolon. And I'm going to go ahead and break as well. And the break is so that we just get out of the loop because we're already done. We've already proven that it's failed. We don't want to print out the messages more than one time. Okay, so by doing this break, we basically said that it should not give us the result more than once. But let's test it. Let's run this. All right, so we're going to run this. Let's do calculate. Okay, so the names aren't valid, so let's throw in some names here so we don't get that test failing. Okay, there we go. So the score for player 1 valid, player 1 is so it's actually giving us it multiple times. Well, we don't want that. Okay, so this break is only getting us out of this for loop. It's not getting us out of this one. So we're still going through each player. But if we right here say if retval, then output this stuff. Okay, so in other words, we're only going to perform this test if we've not failed yet. Once we fail, we're not even going to bother doing the test anymore. Okay, in fact, let's only output this. So I'm going to move this and put this inside here. What we're going to do is, rather than having it, there we go, that should work there. Let me just make sure I've got my spacing and my indenting correct. There we go. Okay, that goes there. So the idea here is we're going to test every one, but only output the message the first time. Once it's failed, we're not going to bother putting out a message every single time. Okay. And in other words, so let's go ahead and test this. So we should only get one error message this time. So again, I have to type in some names. Okay. I'm going to test or calculate. Okay. So that worked. Okay. And I spelled calculate wrong. I got to fix that. Okay. Oh, it only ran once. Perfect. So it only gave us one error message. So let's put in some words. Okay. It still failed. Let's put in a number. Okay, there we go. So score 2 player 1 is invalid. Now I still have to test that this has to be less than 300. Okay, so let's go ahead and do that. Okay, so in here, this is numeric. We can also test an is range. So let's go ahead and private bool is in range. Okay. And we're going to input an integer as the input value, an integer as the min value, and an integer as the max value. We're going to create a little tool for ourselves, basically. And we're going to say return input value is greater than or equal to min value, and input value is less than or equal to max value. Semicolon. Okay. By doing that, we're literally just saying, okay, is it in this range? Okay. So there we go. So if we want this is numeric to actually work better, what we can do is we can actually do what's called an overload by creating an identical name is numeric. Okay, we can go string input value, but then we're going to put min value as an integer and int max value here. So this might be a little confusing for new programmers, but this is called overloading. So I'm actually allowed to have two functions with the same name as long as the signatures are different. Okay, so again, I'm going to go double temp like this, and then I'm going to say if double dot try parse input value out temp, then do this. Okay, right? So what I have to do now is I also, in this case, need this return value. We're going to assume it's true. Okay, and we're going to return that ret val like so. And then inside this if, what we're going to do is we're going to say, okay, if it successfully went into this temp variable, we can now do one more test and say if temp is less, oh no, here we go. Yeah, if not is in range, temp min value max value. Okay, there we go. Oh, this has to be a double. Okay, so let's put this in as a double. There we go. Yeah, there we go. That works. And we're going to put our curly braces here. We're going to say ret val equals false. Semicolon. Okay, so it's going to fail. Okay, so basically what this is saying is if is numeric is first of all, it can be converted and it's in the range. So this one is just whether it can be converted. This one is it converted and in the range? Okay, so up here, we're going to change this is numeric right here to also include min score, comma, max score. Did I do those in the right place? Got my brackets there. Okay, so this bracket's in the wrong place. Right there. There we go. Okay, so essentially what this does is this is going to test for both. So it doesn't, we're just saying is invalid. We're not saying whether it's a good or bad. We're just saying is invalid. So let's test this. Crossing my fingers here. Crossing my fingers. Okay, so we've got this. Let's put in some names so we don't get that test. Let's put in a score of 54. Calculate. We're not getting any errors. Okay, so what's going on here? We should have got errors. Okay, so if not is numeric. So we're doing the same test here. Oh, here we go. We have to say else ret val equals false. So what we hadn't done is we hadn't said, okay, if this succeeded, then we tested. But if this failed, we didn't set this to false. So if this try parse fails, we need to set that to false. See? Don't always get it right the first time. So we're going to go ahead and do this. Let's throw some names in here. Okay, let's throw in 34. It should go. So player 2, player 1 is invalid. Perfect. Okay, that works. Let's put it for this score here. Let's put 452. Score 2 for player 1 is invalid. So even though it is a number, it's still saying invalid because the maximum it can be is 300. Okay, so that's pretty good. The next thing I want to do right away, right now, is because every time I run this and I test this, I'm having to type in a bunch of stuff manually. All right, and that just adds to your testing time. So what I want to do is automate the filling in of the objects. Okay. So right now, before I go any further, I'm going to just collapse up all this stuff because I'm going to just take this to the side for a minute. Okay. And I'm going to create and work in this testing method section. So what I'm going to do is essentially say, if I hit that testing button, I want to pre-fill in the form. So I'm going to double click the testing button. Okay. Double click it. Going to create this testing values. Now this is an event, yes, but this is specific to testing. And the idea is when I'm done, I'm going to delete this button. So once I delete this button, I also will want to delete this as well. It's not a permanent feature of this. So I'm going to make sure that I put this in this testing method. So when I'm done, I just delete this whole section. Okay. So what I'm going to do is in this testing section here, I'm going to go ahead and create some functions to just automatically fill this in. So the first thing I want to do is I want to fill in the names. So to go to the names, I'm going to create a little array, random player names = equals new string array. Okay. And we're literally just going to put a string in here. And we're literally just going to put a bunch of names. I already have a bunch of names here. Let me copy and paste them so I don't have to do everything twice. Okay. So there we go. I put in a bunch of names. Now notice I have some legitimate names here, but then I have a one character name. That should fail. I have a space. That should fail. And I have a name that has a bunch of spaces and one character. So that should also fail. So randomly, as I put this in, I will be able to do this. Now, notice it's giving me an error because you can't instantiate in an array unless you've declared it. So in the global space, which means not in a thing. So this space right here is actually the exact same space as this space as the global variables are in, but I'm not going to put it in the global variables because again, I want to delete it later. So I'm literally going to take this variable here and make this a string array and just declare it just like that. It's in the global space, so this is a global variable. All right, but it's in the testing region, so when I'm done I can just delete this whole testing section. Okay, so let's go to the next part here. And this is where we're going to populate the items. Okay, so we're going to go private void. We're not going to return anything. Populate items. I'm not going to input anything either. A straight up method. So this is an event. This is a method. Okay. So let's do the names. So I'm going to do for each. Okay. And I'm going to do for each text box in the player names. But because I want this to be random, I'm going to need a function which gives me a random number. So let's go ahead and create a function which gives me a random number. Let's just call it getRandom. Okay. We'll give it an int min number and an int max number because you can get, I want to get a number between 1 and 10. So I'd say between 1 and 10. Okay. So get a random number between the min and the max. And the way you do this is there is a pre-built-in type called R. So that's a type, just like integer or string. Okay. So type random equals R equals new random. Okay. And random is a default method built into C# that we can just call. So then we're going to return r dot next random number, and that next random number will be between the minimum number and the maximum number. Give me the next random number that's in that range. Okay, so that's just going to give us a random number between min and max. So when we go back to populate items for the names, remember the names text boxes there are 4 text boxes, but I have, I believe, 12 names in here. Okay, so I'm going to say for each text box, just call it T box, in player names. Okay, so for each one of those player name text boxes, okay, we're going to go ahead and do some stuff. And we're going to literally say tbox.text is going to equal getRandom. Okay, or sorry, it's going to be the random player names, and the index number will be random. So in this random player names array right here, we're going to randomize which index number we're going to use. Get random, and we're going to send in the numbers 0 to 12, I believe. Or actually, you know what? We don't even know how many. Let's go random players dot length -1. Okay, because again it starts at 0. So we're gonna send the length of this as the maximum number we're gonna accept. Okay, and then we need a round bracket there to close that off. Yeah, and then we need semicolon like that. Okay, that should do it. Actually, we don't need that round bracket there. All right. So basically, that's all that's doing is we're literally filling in the names. Okay. Now we can do the scores, and it's just going to pick a random one for this. And yeah, we can get repeats. It doesn't matter for testing purposes. Okay. So for the scores, we're literally going to do another for each loop. and we're going to say for each text box, and we'll call it dbox again, in scores. So even though scores is a two-dimensional array, it doesn't matter if we do a for each. For each will do every single one, regardless of whether it is a two-dimensional array or one-dimensional array. It doesn't matter. Okay. So we're essentially going to do this, and we're going to say tbox.text equals get random. Okay, we're literally just going to put the random number in there, and the random is going to be between the minimum score and the maximum score. Remember, we set those constants at the beginning, 0 and 300, for the best scores that you can do. And because this is a text box, we need a toString to change that to a string, like so. And that's it. That right there. I mean, look how easy that was. We set up a random player string. We put some random names in there, including some that will cause errors, so we can test that the error is working. And then we just literally say, okay, randomize them. Okay. Then we created this random number generator, which is really easy. And then we literally just generated numbers between 0 and 300 inside this box. Okay. Now, to test ones that fail, we'll have to manually type in errors, but that's okay. Let's see how this works. So we've got this error in here. In order to actually do this testing, inside this test value click, we need to execute this populate values, or populate items. So we're going to go ahead and execute that just like so. And there it is. Let's see if this works. Let's go run. And we're going to hit testing. Look at that. We're done. Test, calculate. It works. Okay. Let's hit testing again. All right. Now we've got some errors. There's a name missing here. Calculate. Player 2's name is invalid. Okay. Testing. Okay. We've got some more errors. So we can literally hit test many, many times and test whether it's working. Calculate. Now, if we want to test the scores, we can just go in here and delete and test. Oh, yeah, right. Delete and calculate. Okay, so that one's wrong. Test, delete this one. Calculate. Player 3. Perfect. So this is a really good way to test things. Let's change this to 500. Calculate. Okay, score 2, player 3 is invalid. Perfect. That gets this working really good, and I don't have to type in a bunch of random numbers all the time. So I love that testing feature like that. Okay. All right. So let's get everything else working now. So the first thing I want to do is we got this calculate button, which is the big part of this, but we have the reset and exit button, which I want to just take care of first really quickly because that's a bit of a pain right now. So we're going to close this testing section up. Let's go ahead and bring our form over a little bit. We're going to double click on the exit button. Okay. And we're going to say application.exit. Now, some people want to use you can do this dot close. You can do that. That will work as well. However, there's a difference between application exit and this dot close. This dot close does nothing more than close the current form. Okay? Application dot exit exits the entire application. For the most part, when you only have a one form application, these will do the same thing. Somewhere in the project properties, and this might take me a second to figure it out, but somewhere in the project properties, there'll be a behavior of what happens when you close the form. So if I go here, somewhere in here, there's a default form that you choose. Let me see if I can find it. Sometimes this is hard to find. Package, expression file, build, application, startup object. Okay, so you can set the startup object. Okay, and when you set the startup object, you can say what happens when you close that startup object. Okay, so I'm going to set this back to default by now, but what you can do is you can say what happens when I close the default form. Well, if I close the default form, the default is to close the application. So if the only form you've got open gets closed, then it's going to go ahead and close the application. I prefer just saying application closed because I know the difference between application close and close my form. So later on, when I have multi-form applications, I will use this.close to close the current form, but not close my entire application because I still may have another form open. All right, so I'm going to use application exit in this case because I literally want to exit the entire application. Then I have this reset button. Okay, so the reset button is going to do a bunch of things. Like it's going to make all these blank so that I can enter it again, right? But the problem is this reset button, the concept of blanking everything, I'm not just going to do that inside the reset button. I may also want to blank it when I first load the form, right? So when I blank all these items, I probably want to write this code in a modular format such that I can call it from more than one time. So this is where this general methods comes in. So I'm going to create a private void, so a method called set defaults. Okay, and I don't need to send anything in. And the only thing that this entire method is going to do is literally get this form so that it's in its initial state. Okay, this has got some really cool things in it. Let me show you. Okay, so I want to go ahead and make sure that all of the player names are clear. So you're saying, oh, there's 4 text boxes. That's going to be huge. That's going to take me like text box 1.text equals string.empty, blah, blah, blah. No, you can do a for each because you put it in an array. You can go for each text box called tbox. You can call it anything you want. The tbox is your own name. Okay, so for each text box in player names. Okay, and I'm going to write this on one line. Okay, I only write these on one line and put the curly braces on one line if the executable command block of this is only one line. I'm literally going to go textbox.clear. Semicolon. That's it. That one line right there will delete all 4 text boxes. Will clear the text boxes. And if I literally take this line, copy and paste it, and change this to scores, I now have cleared all 12 scores. So these 2 lines right here just took 16 text boxes and cleared them. And I never named one of them. That's the modularity of setting these global variables up and these form loads up and doing this stuff and setting these arrays up. By doing that, I can now make this extremely easy. I don't have textbox1.clear, textbox2.clear, textbox3.clear, textbox28.clear. I've literally got that, and it doesn't matter how many there are, this will clear all of them. Okay, I'm going to paste that again, but this time I'm going to change this to label, and I'll call this LBL, and I'm going to say player totals. Okay, so what I'm going to do is these 4 labels right here, I'm going to make an array out of them as well. So let's go up to the global variables section. Okay, let's go a label array called player totals, like so. Okay, and then in my form load right here, again, I will move this over. Okay, I'm going to say player totals equals new label array. Okay, new label array, and we'll literally give it the names label where's my, oh there, total P1. Okay, label total P2, label total P3, label total P4, semicolon. Okay, so now I've got all of those 4 total ones, these 4 total labels, into an array as well. Now as they're into an array, I can literally use that as well and just say LBL dot, now you can't use clear on the label, so you're going to say dot text is equal to string dot, or no, let's just make it equal to 0, like so. There we go, that makes sense. Okay, so those are done. Okay, now the only other thing we have to do is these 4 labels here all need to be set to 0 as well. I'm just going to copy and paste this code in for trying to shorten the video a bit. It's already long enough. Okay, so we literally just take the low score, the top score, the team score, and the average score, these 4 labels, and just set them all to 0 by the defaults. And that's it. That's the set defaults done. So everything that I want to reset on the form is reset by 7 lines, even though there are 16, 20, there are 24 objects on that form, and I reset everything in 7 lines. I could put these in as an array as well, but I'm not going to bother. Okay. So when I do this, I have the reset button. I'm going to call set defaults. Boop. Done. Okay. And I'm also going to use set defaults on the form load. So this form load, I'm also going to call set defaults here. So I'm going to force it to set all the defaults when it first loads the form. So I'm going to set it when I first load the form, and I'm going to set it when I call the reset button. So I don't have to write that code twice. Okay, so those are all done. Let's shrink those all up like so. We got the exit buttons done, the reset buttons done, the form load is done. We've got data validation. We've got our general methods here, which is our set defaults. Okay, we've got all our testing methods linked up in here. That's awesome. Okay, and all we have to do now, I think, let's close up the global variables because we're done there. All we have to do now is actually do the calculations themselves. Okay, so let's go ahead and do some calculations really quickly. Okay, this is probably going to take a little bit, but let's go ahead and do some calculations. Okay, so first thing we're going to do is say if it's valid. Okay, if nothing's valid, we're not going to do anything. Okay, so that's the first thing. Okay, so what I'm going to do is with this if is valid, I'm going to add an else if really quickly saying if it's not valid, just do a message box saying calculations cannot happen as values might not be correct. So they get 2 pop-up windows, one saying which box is incorrect, and 2 saying, okay, we can't do the calculations. And that's why nothing over here on the right-hand side changed. Okay? So we've got that. So in here is where all our good stuff goes. Okay? So, but before we get in there, okay, I'm actually going to shrink this up a little bit to save myself some code. I'm literally just going to put this in here like this. Okay, there we go. So I don't need that semicolon right there. Okay, so there we go. We just simplified the code a little bit. We didn't need that extra variable. Okay, but what we do need to do is we need to keep some variables because we need to calculate what the low score is, what the high score is. We need to have a total. And to calculate the average, we also need to put stuff in. So we're going to go ahead and set up some variables. These are going to be local variables that are going to... Now, we're going to have a low score variable that we're going to check that if the score we're checking is lower than the one we think is the current low score, we will change it. So if we set this to the max score right away, that means the first score should be lower than it, right? And if we have the top score, or we'll call it high score, okay, is equal to the min score, that means the first score, unless somebody had a really bad game and gutterballed 10 times in a row, or actually 30 times, you'd have to gutterball 30 times in a row in order to get a 0. But anyway, so if we set the high score to 0, chances are the first score is going to be higher than it, right? So we'll start with worst case scenario, and then go from there. So then we'll go int total score, and we'll say the total score equals 0. The reason why we need to set a total score is because we're going to add it up. So we need to have something to start to add that starts at 0. So we're going to say int total score equals 0. And the last thing is we're going to have an int array. Okay. And this int array is going to be called total scores. And this is how we're going to populate these total scores right here. Okay. So int array total scores equals new int array. Okay, and I'm actually going to set this to be of size max players. Okay, I know that there's only going to be max player scores, so we'll just set that right away. So we've got that set. We've got these local variables declared and initialized. So we're going to go ahead and say if the names and the scores are valid, let's do some calculations. Okay. So first thing we're going to do is set the totals to 0 for the totals array. Okay. Oh, see what happens when you don't yeah. Set the totals array values to 0 to start. Okay, so literally we're going to set this one here, we want to have them all start at 0. Okay, so we're literally going to go for int I equals 0, semicolon I less than max players, I plus plus. And again, I'm going to have a one-line loop, so I'm literally just going to do it here. I'm going to say total scores I equals 0, semicolon. Okay, so all that does is it just says, okay, every one of the elements in this array will start with a value of 0. Okay, so now we're going to do our calculations. Okay, I'm going to do a calculation. So let's go ahead and we're going to do a nested loop because it is a two-dimensional array. So int p equals 0, semicolon p less than max players. Now notice this time I started at 0. It doesn't matter if you start at 0 or 1 as long as you keep track of what you did. So instead of saying less than or equal to max players, I'm just saying less than this time. Okay, and so we're going to iterate through the players themselves. Okay, so iterate through each player, and then for each player, iterate through the games. Okay, so we're going to do that. We're going to go for int g equals 0, semicolon g less than max games, semicolon g plus plus. Okay, so that's going to be our setup loop for going through each game. Again, I started at 0, so I don't have less than or equal to, I have less than. That's just to make sure I stay within the right range. And then literally I'm going to say total scores. Okay, total scores, which is this one right here. Total scores for the player, I guess spell this correctly, total scores for the player plus equals int.parse. Now this is the one that I would say you don't want to use very often, okay? But in this particular case, it's okay because we've already validated. Because we've already validated right here, we know that this is going to work. Int.parse, if it fails, it will literally crash your program, okay? So, but we know it's not going to fail because down here under data validation, we did this try parse. So we have already tested if it's going to work, okay? So we don't need to test if it's going to work again. We already know it's going to work because it passed this test. So if it passed this test, then the parse statement here should always pass. So we're just not going to worry about it. So literally just going to say for each game, for each player, iterate through the games. Add up the total score for that player by adding together all the games, okay? And then once you're done all the games for the player, output the total, okay? Output total to players label. So we're literally going to say player totals. Remember, this was an array. This was an array of labels. Okay, up here under global variables, array of labels, right? So we can say player totals p for the player dot text is equal to total scores p dot to string, like that. So after we've got this total for the player, we can just output it right to the string, to the label right away. Okay. Now we have labels, label totals to check. So as we're going through for each player, we want to say, okay, was the player we just finished calculating less than the low score or higher than the high score? So we'll say if low score, okay, is greater than total scores p, which means is the current low score bigger than the total scores, which means we need to lower the total, the low score. We're going to say low score equals total players scores p. Okay, literally just like that. Okay, and the opposite is true of the high score. So if the high score is less than the total scores, that means we have a new high score. So we'll say the high score is equal to the total, the new high. Okay, and this has to be an S. There we go. Like so. Semicolon. There we go. Okay. So that keeps us track of that. And the other thing we need to do is track the overall total, because we need the overall total to get the average. Okay. So we created this total score variable right here to add that up. So we'll say total score plus equals total score is P. So the total score for the current player. So if we take the total score and add the total score for each player, we'll get the overall total. And there we go. All right. Cool. So we're iterating through the players. For each player, we're iterating through the games to get the game total. So we're going this plus this equals this total. And then what we're doing is we're keeping track of the numbers as we go. Then we can go to the next player. Once we've done, now we can calculate averages and team score. Okay. So we're going to say that we have to convert to doubles, because this is going to be some integer math here. But anyways, we'll say double average score is going to equal, we're going to round because we're doing some integer math. So we're going to round. Okay. And we do that with math.round. Round is capital R. And we put in what we're going to round, and I'm going to round that to 2 decimal places. Okay. So that's how we do math.round. Okay. And so what I'm going to round here is I'm going to convert to double. Okay. Convert to double the total score. The reason why I'm converting that to a double is because it is in fact an integer. Okay. As total score integer. But the average isn't an integer. Okay. And we're going to divide that by converting to double the max players. Okay? Like so. And I spelled convert wrong. Not covert. It's not the CIA or anything like that. It's convert. So convert to double total score divided by convert to double max players. Okay? And that will give me my average. Okay. The other one we have to do is the team score. So the team score, okay, is going to equal, did I set a team score initialized here somewhere? No, double team score is equal to, again, math.round because it's an average. Okay. So we want to round it like so. Okay. And then I want to do here convert dot to double total score, but I want to take away the lowest score. Remember, the team score is the average of the top 3 scores of the night. So in other words, if I take away the low score, that will give me the total, and then I'm going to divide that by convert dot to double the max players minus 1. Okay. And that will give me my team score. The math's irrelevant here. That's not what I'm trying to teach here. It's just making sure that we don't do integer math, because when you do divide by integer math, you get totally different answers. So make sure you're doing decimal math. Okay. So we convert those to doubles. And then literally now we just do the output section. So we say label low score dot text is equal to low score dot toString. Easy enough. Label top score dot text is equal to high score dot toString. We say label average score dot text is equal to average score dot toString. And we say label team score dot text is equal to team score toString. Like so. There we go. Woo, that's a lot of code. That's 257 lines of code, and that's with with very little commenting. Like, I haven't done any other commenting yet, but let's test. Time to test. Okay, let's hit the run button. I don't see any red dots on the right hand side here, so let's test. All right, up comes the form. We're going to throw in the testing data. That's going to fail, but let's put in a name just to see here. Okay, let's calculate. Holy cow, we got some numbers. All right, so we've got some numbers here. So 64, 120, 255. Yeah, that seems right. 171 and 91 is about 260. Plus that's about 430. Okay, that's pretty good. I'm just estimating here. Okay, so the numbers seem pretty good. So this is like 200 plus 200 plus 250. So 650, that's about right. And so our top score, the highest one is 655, right? The low score being 300. So we got to figure out what that one is. Oh, because we used max score. Ah, that's right. So 300 is not right. So we need to make sure that our low score can actually be the max score times 3 because you're playing 3 games. Yeah, we got to make sure that the 3 games is taken into effect. Okay, but the average score is 498. That looks good. And the team score is the average of the top ones. So take away the 431 and the average of these ones. 560 seems pretty good. Okay. All right. So let's go ahead and fix this low score one because that's not working. Okay. And the way we do that is where we initialize this low score. When we initialize this low score, we initialized it as 300, but none of the scores were less than 300, so it never moved. So this should actually be times max games. So max score times max games, so that the maximum you can get over 3 games is going to be 900. So this is going to be 300 times 3. Let's run this again. Test it. See, this is why we... So if I didn't have this testing button, how many tests would I have had to have done to find that error? Right? There we go. We got a 345, which is the low one. Perfect. So there we go. We've got that all good. We've got that testing done. What I'm going to do is say exit here, and I'm going to take this testing button, and I'm not going to delete it, because if I delete it, again, this is for beginner programmers, so I don't want to delete this testing button because it can cause me a problem if I delete it. But if I highlight this testing button, oh, sometimes Visual Studio does this. Like this seems to be broken. Just close it and reopen that designer again. Okay. If I go to this test button here, I go to the properties, I'm literally just going to make it invisible. So I'm going to make visible equals false there. And now when I run my form for like the client or whatever, that testing button is gone. You can't see it. Okay. And because you can't see it, you can't click on it, etc. So there's my form and I'm done. So lots of things that I covered today, a pretty long video. You probably have to pause it and hit and go through that a few times. A really good example of modularity, breaking things down, code organization using these regions. Because notice there's all of my code right there on the screen. Like, isn't that nice and tidy, right? And I can even shrink this one down. There we go. We are even smaller. Well, I introduced this concept of the testing. In modularity, we use the concept of making arrays of objects and then iterating through those arrays. So when we did this data validation, rather than doing it for each one, like imagine all that code I had here for the 4 names. Imagine doing that for the scores. I would actually have 12 of them, right? I'd have to test each individual text box separately. But by putting them into an array, I'm able to write a loop. I mean, this right here, probably take a few of you some minutes to try and figure out that line. The rest of it's fairly straightforward, but that line's probably a little bit confusing, so take some time, figure it out, work it out on your own, and it'll come to you, okay? But this is a whole lot easier than doing it 12 times. And what if those 12 were... Okay, that's only one team. How many teams are in a league? 20? 30? So you have 12 games for 30 teams. You're talking 360 games. Are you going to write 360 tests to validate them? No. You're going to write one test. And that's what we did. Okay. So the idea of the other one that we introduced, which was going to be new and we'll talk about more in depth in a later video, is this concept of isNumeric, where you have 2 functions with the same name. and you can overload them by giving them different signatures. And this is true in most languages. You'll see this in C++, you'll see it in different languages, but that's a really powerful concept. So we were able to use this one in order to get this thing. We could pass this min and max value through to this isInRange function, which allowed us to really simply do this test. So although some of these functions are only one line, it's a lot easier because now we can put these one lines, converting that to a Boolean variable, so we can put it inside of an if statement, which makes it really easy. So those are kind of the things that we do in modularity to simplify our life and to make things a lot easier. And not only that, but these functions can be used over and over and over again in all of our programs in the future. So copy and paste these ones and keep them around, because you can copy and paste them back into your other programs later. All right, I'm going to wrap up this video now. It's been a busy video, a long video, but hopefully you guys enjoyed this and it taught you guys lots of stuff. Thank you.